Okay, when we want to solve exponential equations like this, the important thing, like when we're dealing with the logarithms, is that we have the same base. Right? So a couple of people looked at these already last lesson, but if we want to solve, I'll do that one, 2 to the power of x plus 1 equals 4 to the power of 2x. Now, the unknown, the variable that we're trying to solve for is the exponent. We chuck this in because we could write logarithmic statements to bring the x's down, but we're not in this case, right? Just to show you that we don't always need logarithms, kind of in the same way that we were doing our rational functions. If I can make the bases the same, then the exponents must be equivalent to each other. So using my laws of indices, I know that 4 is the same as 2 squared, and therefore the base can be the same. So if I rewrite this as 2 to the power of x plus 1, I can then change 4, if I put brackets around, to being 2 squared to the power of 2x. And then if you remember your laws of exponents, which hopefully we will, because we're going to apply some of those very similarly with logarithms, when you've got exponents like that, what do you do? We have x to the power of m to the power of n is equal to x to the power of m times n, right? So then that becomes 2 to the power of x plus 1 equals 2 to the power of 2 times 2x is 4x. Now we're kind of having a logical statement like we did with the rational functions, where if the base is the same, then the exponents must be equivalent to each other, right? So we can now just say, without doing anything other than logical reasoning, we can say, well, x plus 1 must be equal to 4x. And we solve that. Subtract the x. Gives me 1 equals 3x. Then we divide by 3. Gives me x must equal 1. Okay? All right? Okay. Let's, have you written it? Let's have a look at one of the others then. So, which one, would you like to just do some others yourself for 5 minutes, or should I go through another one with you? What do you think? Okay, go for it. Right. What about this one now? Just to start this one off before you even. What do I do with the half? Okay, so that's the way to do this one, isn't it? It's 2 to the power of negative 1 to the power of 2x. So that will enable you to carry on to. So we've got 2 to the power of x plus 1 equals 2 to the power of negative 2x. Therefore, x plus 1 equals minus 2x. Which means 3x equals negative 1. I kind of did 2 steps there, so I added the 2x to both sides to make the 3x, and then I subtracted the 1. So, ladies and gentlemen, when we are solving, now this is going to be quite applicable to an important thing, which is we are going to need to solve an exponential equation where the x is the exponent, which is a hard thing to look for. And at the moment, we've had questions, if you remember doing exponential growth and decay stuff, where what we did was we had a trial and error approach, all right? Or we had a graphing approach, where we used to graph both sides, right? So, for instance, I don't know whether you remember, but if I wanted to solve 2x equals 5, and I have my calculator, I have my computer, what you would be doing is you'd be graphing y equals 2 to the power of x, and then you would be graphing, rough sketch, y equals 5, and you'd be finding the solution there, wouldn't you? Right, remember doing that? Using decimal to solve it, which is a perfectly reasonable thing to do, but if we don't have access to that kind of equipment, or we're trying to simplify things, we don't want to do it in that way, we need another method. And the way we're going to be doing it now is in using logarithms, right? So think on the next set of questions after this are going to be application in real life stuff. So let's have a look. If 2 to the power of x equals 5, and we're being asked to solve that in a different way, not graphically, do you remember how we do it? So we'll change the subject, so we do log to the base 2 of 5 equals x. We need that on our calculator. So next year, when you've got your graphical calculator, no problem. Super easy, just chuck it in. This year, because you don't have your graphical calculators yet, what do we need to do? We're going to do log to the base 10 of 2 over log to the base 2 of, sorry, log to the base 10 of 5. What did you get? Is it the other way around?
Yes. Otherwise you get 0.4.
Okay. So that's a good thing. Remember to check.
2.322. Excuse me, sir.
What is it? 2.32. Okay. It does say give your answer to 2 decimal places, so we're okay. Let's have a look at the next one. 5 to the power of x minus 1 equals 3. 5 to the power of x minus 1 equals 3. Okay, again, logarithmic statement. What is it? Log to the base 5 of 3 equals x minus 1. And then we do what we've done in the past anyway. If we add 1 to both sides, we've got log to the base 5 of 4 equals x of 3. Why not?
That doesn't seem right.
It doesn't seem right. It makes no sense.
Same reason 2 squared plus 1 is 3.
Well, come on, question these things. I've done it because I see that so often. But you've got to say, it's like, do it. Why doesn't that make sense? Because look what we're saying. 5 to the power of something equals 3. If I do this, I'm now saying 5 to the power of something now equals 4. That doesn't make sense, right? The power, maybe we can subtract 1 from the power, but we don't change, what the value is here. This is 3. So, yeah, it's a case of don't do things that don't make sense. So I'm actually going to do something we've done before. So I'm going to write it on that side because I don't want to get it mixed up. Now again, we can just evaluate this using our calculator. So it's going to be 1 plus log to the base 10 of 3 over log to the base 10 of 5. And what do we get? That makes sense? Because that basically says 5 to the power of 0.68 equals 3. It does make sense, right? Because if it was more than 1, it would go higher than 5. But if it's less, between 0 and 1, it's going to go less than 5. So yes, it does make some sense. Alright. Okay. You get to do, no, that's M2s. Genuinely M2s.
Well, that looks. I probably remember like being like, oh, I don't understand this. How does this work? Look at
And now you're saying it's super easy.
Yeah.
So should we test them?
Mr. Boss, do you teach myself?
Okay, so your first statement, I presume, was to write log to the base 2 of 5 equals 2x plus 1. So we then have 1 plus log to the base 2 of 5, all divided by 2 equals x. Am I right? Good. It should be subtract 1, so I can put minus 1 plus. Yeah? Or you could put minus 1 afterwards, whatever. But you know. It depends what you're trying to say there. I think what might be easier in this case is to say log to the base 2 of 5, then minus the 1 afterwards. All right? Or minus 1 plus at the beginning, up to you. All right? All of it divided by 2. So then we've got log to the base 10 of 5 divided by log to the base 10 of 2, all of that minus 1, all of that divided by 2. Do it step by step. This is why not having to do the change of base with a better calculator really. So, what would be your first step there? That wouldn't be my normally first step, but yeah, that's what I'm getting at. Normally people would divide by 4, right? Yeah? So you divide by 4, and you get 2 to the power of x equals 6 divided by 4, and then you would just do your, like you just told me with the other one. No? Well, that is one option, and then we would do log to the base 2 of 6 over 4 equals x. We just do that, right? That's one option. But, as Steph said, what we could actually do is say, well, 4 is 2 to the power of 2 times 2 to the power of x equals 6. And what does this then become? 2 to the power of x plus 2 equals 6. So then you get log to the base 2 of 6 equals x plus 2. Alright? Either way, I don't know what you consider is more easier, but whatever stage we're at, this one I can now just work out my calculator. This one I've still got a minus 2, but you know, either or. The options are there. Right, so you have these things if you want to do some more practice at home. What we're going to talk about next time is using the logarithms to solve the equations that we've relied on our graphs before. So it's all like we've done before. We're going back to our growth and decay stuff. You recognise the formulas that you've come up with. You recognise doing this So at this stage before we'd have put it into a graph, but now look, we've got this logarithm with an awkward looking base. We can either do that using change base, but if you've got a calculator with it on, then we can solve that much easier, well, easier, but without using graphs, right? So that would be our final point, and then we need to learn about the laws of simplifying logarithms and things, so we can get to this simple step. But it'd be quite nice to give you a question along that sort of lines. I can probably take one from the DP course, lots of them around, solving a real life question like that, and that can be a quick little assessment somewhere. So we'll pack up now so Steph's got time to pick up all his shavings off the floor that he's just chucked there. Because I'm not doing it. The rest of us can pack up.